Okay, so today we're going to look more at transformations, and we're specifically going to look and see what happens when we've got multiple transformations happening in combination, and then a new type of notation called mapping notation. So let's start with combos of transformations. So if we have combos of transformations, what we need to know is that order matters. Okay, so this is, and it's based on order of operations. Here's the deal. When you have multiple things happening, so for example, let's say we have negative f of x minus 2. Let's say this is a transformation that's happening. The first thing that always has to happen if you're going to kind of work graphically in order is your flips, so your reflections. So you always flip first. So for example, if we had something that looked like this, let's say we drew ourselves a nice little triangle, and let's see, we had a triangle here that looks like this. Here's our original triangle, okay? This is our f of x. And we want to transform that. We would flip this. So our first stage of our transformation would be a vertical flip. And we would flip it, and it would look like this. We'd be like, okay, we're going to flip it. And then what's going to happen next? Next, we would do any stretches. And do we have any stretches happening here? No, we don't. So our third thing is going to be our slide, or our shift, or our translation. So in this case, we're shifting which way? We have a horizontal translation, so we are going to shift to the right by 2. So now I'm going to take my triangle, and I'm going to take this one, and I'm going to move it 2 over here, and I'm going to take this, and I'm going to move it 2 over here, and this is going to move 1, 2 right here. So my final triangle is going to end up having moved 2. So this is my negative f of x minus 2, my new triangle. Okay, so whenever we've got multiple transformations happening, we need to go in this order. Pause the video, write this down, it's important. Okay, now let's talk about mapping notation. Mapping notation is an additional notation that's going to do exactly what it says. It's going to give us a map for our coordinates. So mapping notation shows transformations in coordinate format. Okay, in coordinate format. And when I say coordinates, I mean like x, y. So horizontal transformations change x, and that happens with opposite math. And vertical transformations change, which one? Yep, change y. And they use regular math. So as an example, let's say we originally have the function y equals x squared. So that's quadratic. The coordinates don't care that this is a quadratic function, right? Like if I was going to draw the coordinates for that, I would have x, y. But let's say I want to transform that. If I want to transform this quadratic to y equals x squared plus 2, is this addition of 2, is this happening vertically or horizontally? Like if you drew this parabola, what are you doing with it? Well, it's going up 2. It's not moving it left or right. It's just moving it up. So all that's impacted are the y's. So we would write this mapping notation as x comma y plus 2. So all it's telling you is that in this new transformation, all of your existing y coordinates are going to move up 2, and you just leave your x's alone. If it was horizontal, it would look something like this. Let's say x plus 2 squared. So in this one, you're sliding everything right or left, and you're not going up or down. So when you draw your mapping notation, if you start off with x and y, your x's are all changing, and they're all going to shift 2 to the left, right? So they're going to go down 2. And your y's aren't going anywhere. So the mapping notation would look like that. So let's do a full example here. Let me get a graph, and I'll show you what I mean. Okay, so here's my graph. Let's say I'm gonna go back to my my friend, the rectangle here. So this is my f of x. Okay, this is my f of x, and it's got coordinates that are, let's see, it's got 1, 1, and it's got 5, 1, and it's got 3, 3. Okay, so here's my coordinates. Let's say we are going to transform this, and we want to have negative f of x minus 3. Okay, so what's going to happen here is first I'm going to think to myself, what transformations do I have? Well, I have a vertical reflection, right? That's this negative. And then I have a vertical translation. I have a vertical translation. So I know that this is going to flip and then slide. And we just talked about how order matters. So if I was going to kind of look at my triangle in stages here, I know it needs to flip over the x-axis. And if I do that, it's going to kind of land, it's going to land right here, right? It's going to land here. And then I need to drop it another 3. So if I drop everything 3 times, I can take all of these points, like kind of my corners, and just slide them all down 3, right? So 1, 2, 3. If I know how to do this, 1, 2, 3, 1, 2, 3. Okay. And here's my new triangle, right? Now, let's talk about where these coordinates are. Well, this coordinate right here is at 1, negative 4. So this transformed to 1, negative 4. And this bottom point transformed to what? It transformed to 3, negative 6. 3, negative 6. Oops, oh, sorry. I wrote that in the wrong spot, didn't I? The bottom point right here transformed to 3, negative 6. And then this right point transformed to 5, negative 4. Okay, so let's start by looking at our x's. I had a 1, a 5, and a 3. In my new one, I still have 1, 5, and 3. So that means my mapping notation, x didn't change. So I didn't even touch my x because I didn't have any horizontal. I only had vertical. So my x didn't change. What happened to my y's? So my y's went from 1 to negative 4. Mathematically, how do you go from 1 to negative 4? You subtract 5. This went from 1 to negative 4. Subtract 5. This went from 3 to negative 6. Interesting. It doesn't work anymore. So I needed maybe a new plan. What happened here? Well, what really happened is you multiplied by negative and then you subtracted 3. So let's try that. If I take my y and I make it negative and subtract 3, will it work? So negative 1 minus 3, negative 4. Negative 1 minus 3, negative 4. Negative 3 minus 3, negative 6. So all the y values were negative y minus 3. So this is my mapping notation. All it's doing is creating a little cheat sheet for your coordinates so you know where to move them. And you can directly take your f of x notation and translate it right onto your mapping notation. Okay, let's try one more. Okay, let's say we have y equals 4 times x minus 2 cubed plus 3. So the first thing we want to find is our f of x notation, and then we want to find our mapping notation. All right, so let's try this. Let's make sure we know what's happening here first. We've got a 4. We have a negative 2, and we have a plus 3. I am ignoring this cubed because it's not a transformation. It's part of the function, which is not a transformation. So my 4 is outside the brackets, so this is a vertical stretch. My negative 2 is inside the brackets, so it's horizontal, and it's a translation because it's moving left or right. And this blue plus 3 is outside, so it's vertical. It's moving it up, so this is a translation. So that means all of my verticals are going to happen to the y, and my horizontal is going to happen to the x in my mapping notation. But let's start with f of x. We're going to rewrite this as 4 f of x minus 2 plus 3. All right. Now we're going to convert this to mapping notation. So when we start with mapping, I like to draw my x and my comma y. Now the verticals go on y. So this 4 is going to happen to the y. The plus 3 is also happening to the y. It's outside the brackets. It's vertical. The minus 2 is happening inside the brackets, so it's happening directly to the x. And remember, in horizontal we do opposite math. So negative 2 becomes plus 2. There's my mapping notation. Last one. What if we have something like this? Y equals negative root x minus 3 plus 6. There's no brackets here, but my inside is now determined by this radical. The radical is functioning as brackets because we're thinking in terms of order of operations. So my negative is vertical and it's a reflection. This negative 3 is inside, it's horizontal, and it's a translation. The 6 is outside, it's vertical, and it's a translation. So my mapping notation, again, I'm going to just draw my x, comma y, and then my vertical reflection happens to the y, throw a negative. My horizontal translation is opposite on the x, so plus 3. My vertical translation is plus 6 on the y. That's it, I'm done. Okay, I hope you took good notes on this. Let me know if you have any questions.